In this section, we are analyzing graphs of functions. So we're going to say what we can see about a function by looking at the graph of that function. And in a way, the graph of a function tells you everything there is to know about that function. Because after all, what is a function? Well, one thing we said was it's a set of ordered pairs. Well, what's a graph? It's a set of points, and each one of those points has an x and a y coordinate, an ordered pair. And if you think of a function as like a machine that you put numbers into and it does something to them and gives you a number out, then for each point on the graph of that function, the x coordinate of that point is what you put into the function, and then the y coordinate that goes with it is what comes out of the function when you put that number in. So for every point on the graph, you've got x and then y is f of that x. So we can define a function, we can give an equation or a formula, but lots of times it's easier to tell what's going on with the function if we have a graph to look at. Here's an example. So I don't remember if it's our book or a different book, but I found this formula here for the population of Connecticut in how many thousands of people live there for the years 1991 to 2002. Here it is given by this equation, the population as a function of the time or the year. So if you plug in 1, it gives you the population in the year 1991. Plug in 2, tells you what the population was in 1992. Plug in 3, you get the population for 1993 and thousands of people, and so on. And then it asks about, like, during what years was the population increasing? When was it decreasing? Well, it's hard to tell just by looking at that equation. We could do some calculations with it, actually plug in some numbers and get some numerical data that way. But let's look at the graph. So I got my graphing utility, my graphing program, and I asked it to draw the graph of this function. And here's what I got. So looking at the graph for the t values from 1 to 12, we can see that during most of that time, the population was going up. It started by going down just a little bit from 1991 to 92, but then it came back up and it went way up after that. And do you think it'll keep on following this formula? Well, I just showed the part of the graph that corresponds to t being from 1 to 12, because that's really the only time when this formula is supposed to be valid. But if we look at the whole thing, it looks something like this. So it's probably not true that all of the points that make up this graph, even outside the interval from 1 to 12, show what's going on with the population of Connecticut. It probably only applies to those years. But if it did apply, then that would say that the population continued to grow until, looks like the year when t is 15, so that would be 2005, and then it started coming back down. And who knows how far it would go down, but like I said, I don't think this really applies outside that interval. Okay, so now we are going to look at a graph and see what we can see about that graph. If you have the printed notes for this section, you have this graph at the top of the notes, and then you have a bunch of questions about the function depicted in this picture. So the first question is, find f of 0 and f of -6. So remember the points on the graph, the x-coordinate is what you plug in, and the y-coordinate is what you get out. So if we're talking about f of 0, we're plugging 0 in for x, and the point on the graph with 0 for its x-coordinate would be this point right here. So the y that goes with it, the f of 0, is 3. What about f of negative 6? So now we're looking for the point on the graph where the x-coordinate is negative 6. And then the y-coordinate would be f of negative 6, which is negative 3. Now see if you can do these next two. What is f of 6? 0. What is f of 11? 1. What about f of 3? That would be the point on the graph where the x-coordinate is 3, and I can't tell exactly what the y-coordinate is. Looks like it's somewhere between 3 and 4, but I can at least say it's a positive number. It's way up here where the y's are positive. And what about f of negative 4? Can you see the point on the graph that would refer to? That would be right about here. And I can't tell exactly what it is. Looks like it's about negative 1, but it's definitely negative. For what values of x is f of x equal to 0? So remember, f of x is your y-coordinate. So we're looking for points that have a y-coordinate equal to 0, and we're supposed to say what the x-coordinate is. So on the graph, do you see any points with a y-coordinate of 0? I do. In fact, I see 3 points like that. There's one there, and there, and there. And what are the x-coordinates for those points? Negative 3, and 6, and 10. Now for what values of x is f of x greater than 0? Now we're looking for points with y-coordinates that are greater than 0, that is, positive. So all of these points that make up the graph, some of them have positive y-coordinates, and some of them have negative y-coordinates. The positive y-coordinates are the ones that are up here above the x-axis. And when does that happen? Well, that happens on this section of the graph here, which is where the x's are between negative 3 and 6. And then it also happens on this section over here, where the x's are between 10 and 11. So for what values of x is f of x greater than 0? Answer, for x between negative 3 and 6, and also for x between 10 and 11. And there I included 11. X is greater than 10 and less than or equal to 11. Notice the graph doesn't keep going past that point. We kind of stop right there. So what is the domain of this function? The domain is the set of all possible values for the x-coordinate. Everything that you can put in for x. So if you look at all the points that make up this graph, they have x-coordinates that run from negative 6 over to 11. And it shows the graph stopping there. It doesn't keep on going. Some graphs do keep on going, but this one just only has points from negative 6 to 11 as far as x-coordinates go. So for the domain, we can say x is between negative 6 and 11, greater than or equal to 6 and less than or equal to 11. Or we could just say the domain is the closed interval from negative 6 to 11. And what about the range? The range is the y-coordinates, what y can be, what can come out of the function. So looking at the points that make up this graph, they have y-coordinates that go from what up to what? Well, the lowest y-coordinate is negative 3, and the highest is positive 4, and we do hit all the points in between, all the y-coordinates in between. So the range is y's are between negative 3 and 4. Y is greater than or equal to negative 3 and less than or equal to 4. So we can say that's the closed interval from negative 3 to 4. what are the x-intercepts? Okay, that's easy. We know what to look for. This graph touches the x-axis at the points -3, 0, 6, 0, and 10, 0. Those are the points we pointed out before when we were looking at where f of x equals 0. And what is the y-intercept? The graph crosses the y-axis here at the point 0, 3. How often does the line y equals 1/2 intersect this graph? So, first of all, picture what that line would look like. If you actually have this graph in front of you printed out, try drawing that line. Remember, when you have y equal to a constant, just some particular number, the graph is a line that goes right straight across, a horizontal line. So for y to equal 1/2, we just go right straight across where all the y coordinates are equal to 1/2. So how many times does that intersect the graph of the function? 1, 2, 3 times. Now, how often does the line x equals 5 intersect the graph? Imagine what that looks like. A line where x equals just some number would be a vertical line, straight up and down. So here's x equals 5, and it intersects the graph once. For what values of x does f of x equal 3? So what's x when f of x, that's the y coordinate, is equal to 3? Okay, here's a hint. There's 2 possibilities, 2 points where that happens. So what are the x coordinates of those 2 points? 0 and 4. And for what values of x does f of x equal -2? -5 and 8. On what interval or intervals is this function increasing? So if we go along from left to right, if we ride the roller coaster, part of the time we're going up, and then we come down, and then we come back up, and increasing is when we're going up. Like when we were talking about when was the population of Connecticut increasing, during what stretch of time, what years. So when is this function increasing? Well, it's increasing on this interval here and also on this interval here. So this interval here would be where x's are between -6 and +2. Whenever we talk about an interval where a function is doing something like increasing, we're talking about what the x coordinates are, what section of the x-axis or the domain of the function. So this would be the interval from -6 to 2, and then this would be the interval from 8 to 11. So on those 2 intervals, the function is increasing. And then in between, we've got the interval from 2 to 8, where the function is decreasing. We will talk more about increasing and decreasing and look at some more examples in a little while. But let me end this video here. We're done talking about this particular example with this graph right here, but we've got a bunch more things to talk about.